Hello everyone. Hola a todos. Welcome to another broader webinar. And first of all, we want to thank the presence of each of you. The webinar will be presented in English, Spanish, and Portuguese, and you will be able to select the language of your preference on the screen. And you will also find a space to make your questions, and at the end of the webinar, the speakers will give us their comments. Today, we will talk about how to improve the use of calcium and phosphorus in the mother broiler. For this, we will have the participation of two professors with great international recognition in these topics. First, Dr. Douglas Corber, professor at the University of Alberta, who will present aspects related to the calcium and vitamin D3 metabolism. And then Dr. Alex Mallorca, professor at the University Federal of Paraná, who will talk about the phosphorus metabolism, phytases, and possible synergies with vitamin D3. To start, I want to comment that genetic selection in broilers is constant. Traditionally, the goal of this selection has been to increase growth rate, meat yield, and feed efficiency. However, these improvements can increase the physiological demands of some nutrients, and the fact of not meeting this increased demand can at some point bring undesirable consequences. For example, problems related with a poor skeletal integrity can still be found today, and those can be a consequence of an imbalanced mineral metabolism and nutrition, especially with respect to microminerals such as calcium and phosphorus. On the other hand, it's very well known the necessity to have a balanced diet with a more efficient cost, and these two minerals, especially phosphorus, has a huge impact. So I am Carlos Lozano, manager for Latin America of Special Nutrients at DSM Animal Nutrition and Health. And to begin the webinar, I will leave the floor to Dr. Corber.
Thanks, Carlos. Many thanks to DSM for the invitation to speak with you. Good afternoon. Good afternoon to all my friends in Latin America. Oh, and today I'm going to talk about calcium metabolism function of vitamin D and hide in agriculture, and first we need to discuss some basic principles. So let us go talk about the functions of calcium in beekeeping. We think of calcium in terms of bone structure, bone metabolism, but it is important to remember that calcium is critical for muscle contraction, nerve transmission, healing, blood clotting, and cell metabolism. And let's talk about other functions, but let's focus on bone structure. It's one thing to remember that serum calcium levels are regulated very closely when calcium is low in the blood immediately. If signals are released to normalize the level when there is low serum calcium level due to increased calcium use or due to low intestinal absorption. A parathyroid hormone is released by the parathyroids to reach the kidneys, where it has two actions. Increases the activation of vitamin D, 1,25-hydroxyvitamin D3 that formative, and also stimulate the kidneys to increase the reabsorption of calcium from the blood. This activated vitamin D also influences the intestine, where it increases the active transport of calcium and also has a direct effect on bone, leading to release of calcium and phosphorus from bone to raise serum calcium levels to normal high levels. On the other hand, when calcium levels are high, parathyroid hormone is not released. There is thyroid calcitonin release, reduce activation of vitamin D in its active format, also acts in the intestine. This vitamin D reduces the active transport of calcium, the kidney, and loses more calcium, more stress pants in urinate, and then the inhibition of bone degradation, inhibiting the excessive release of calcium, and this normalizes the serum calcium level. Now let's talk a little about the intestine and calcium absorption. We have two mechanisms of calcium absorption by intestinal cells. From the intestinal lumen on the left of the graph here, from the slide in this diagram.
You see the lumen of the intestine, And the active transport of calcium involves absorption of calcium into the intestinal cell, binding of calcium to calbindin, and then through an energy-demanding transport process into the blood. So this typically is, because it's an energy-costly process, it is usually used when the calcium demand is high or when dietary calcium is low relative to requirements. And so this is a means by increasing the efficiency of absorption. And of course, this involves the activation of the vitamin D receptor, which binds vitamin D and causes genetic changes or gene expression changes within the enterocyte. Now, there is a second calcium transport mechanism, and this is called the paracellular transport. And so it involves calcium being absorbed into the enterocyte and then secreted through a non-active transport, or calcium absorption through the intracellular spaces, so in between the enterocytes. This mechanism requires no energy, and it is most important when there's high dietary calcium relative to the requirement, or when the requirement is low, and so the body doesn't need to expend energy to absorb calcium. And this is independent of the active form of vitamin D. So we can see that the active form of vitamin D is particularly important at increasing the efficiency of calcium absorption. Now, in growing birds, the vast majority of the dietary calcium that is absorbed is for use in bone growth and bone maintenance. And so the dietary calcium requirement of broiler chickens largely reflects the need to support bone growth. And so we can talk about the requirement of the bird for calcium, but normally there is calcium is required in about a 2-to-1 ratio with available phosphorus, and there is some flexibility in terms of the absolute amount of calcium that is required in the diet based on its relationship to available phosphorus in the calcium in the diet. So that 2-to-1 ratio is largely based on the fact that the vast majority of calcium is used to synthesize bone mineral. That bone mineral is called hydroxyapatite, and you can see the chemical formula here, and it's approximately a 2-to-1 ratio. So this is really what drives the requirement for calcium in the bird. Now, I'm going to talk a little bit more about bone development and bone growth. So I want to set that up. And so if we look at the gross structure, so if we look at the bone tissue itself, it's organized into structures that include what are called osteons, and at the center of the osteons are Haversian canals. And we'll come back and talk about those later. But bone is not just a calcified material. It also involves an organic matrix, and so these collagen fibers are then mineralized with hydroxyapatite, and this gives the bone both strength because of the calcification, but also resilience because of the flexibility coming from those collagen fibers. Now, we're going to focus on calcium metabolism from the standpoint of intestinal uptake and bone growth and development, but I just want you to be aware that calcium is very important in the function of muscles and muscle growth, immune function, antioxidant regulation, cardiovascular health, neurological function, skin health, the gut microbiome, and also adipose function. And those mechanisms are largely involved the vitamin D receptor and vitamin D metabolism. So let's talk about vitamin D metabolism, particularly in the context of commercial poultry. Now, we know that animals are capable of synthesizing their own vitamin D when there is exposure of the skin to sunlight. And so if a wild bird, has a lot of exposure to sunlight, that bird can make its own vitamin D, and it's not required in the diet. However, in commercial poultry production, we typically have an environment where the birds are not exposed to direct sunlight. And so they are not able to make that conversion of the cholesterol-based precursor into vitamin D3. And so we typically supplement the diet with vitamin D, and that vitamin D is absorbed from the gut and is converted in the liver to 25-hydroxy vitamin D3. Now, this is a natural metabolite, and it's also the main storage form of vitamin D in the body. It's also the main form that's transferred from the mother into the egg. Now, there are certain circumstances where we might supplement 25-hydroxy-D3, or high D, which again is this first metabolite, this first natural conversion product that is produced in the liver from dietary vitamin D. Now, in certain cases, for example, with very young birds or cases where there's liver damage because of mycotoxins or other disease situations, the ability of the liver to convert vitamin D into 25-hydroxy-D3 is limited. And so in that case, it's particularly beneficial to supplement a form that bypasses that conversion in the liver. Now, this is the main storage form, the 25-hydroxy vitamin D3, and part of the tight regulation of calcium metabolism in the body is regulated because of this conversion in the kidney. This conversion step is very tightly regulated, and so 1,25-dihydroxy vitamin D3, which is the active form, is only produced when necessary to increase the absorption of calcium from the intestine. So it's not important that you memorize the structures, but I just want to go through that process again. This is the natural, progression. So vitamin D3, whether it's synthesized in the skin or whether it's consumed in the feed, most of it, under normal circumstances, is converted almost immediately in the liver after absorption to 25-hydroxy-D3. That is the circulating pool. This is the storage pool of inactive vitamin D, and when it's needed, it's converted in the kidney into the active form. I should note that these two figures have been switched. I noticed that as I was reviewing today. But the active form is 1,25-dihydroxy vitamin D3. When vitamin D is present in excess or calcium levels are high, then the kidney can convert the 25-hydroxy-D3 into 24,25-dihydroxy-D3, which is the excreted form. And so this is how the body regulates the amount of active vitamin D that's present in the body. So again, just to summarize the functions of active vitamin D, it has a positive effect on calcium absorption at the level of the intestine. It has a positive effect at the level of the kidney in terms of retaining calcium and preventing calcium from being excreted. And it also is involved in resorbing or breaking down bone tissue to release calcium into the blood to normalize blood calcium levels when blood calcium is low. And we're not going to talk much about this today, but there are a lot of extraskeletal activities of vitamin D in immune function, in muscle growth, in nutrient absorption, and so on. Okay, so if birds can synthesize vitamin D through UV exposure in the skin, why do we still need to supplement? Well, of course, in controlled environments such as tunnel ventilated houses, those birds are not getting any exposure to ultraviolet light. And even in open-sided houses, there's not enough, or there's often not any direct sunlight reaching the barn and reaching the birds in the barn. And so with tarping and in some cases excluding light in the case of broiler breeders, broiler breeder pullets, those birds certainly aren't getting enough. And so we need to supplement the feed with a form of vitamin D. And traditionally that's been vitamin D itself. More recently that's been through supplementing high D. And there are also other forms of vitamin D available for commercial supplementation of feed. Now, I'm going to focus on 25-hydroxy-D3 in particular, and just remember that this is a natural vitamin D metabolite. It's that first conversion step of vitamin D along the metabolic pathway, And the advantage is that it bypasses liver conversion. There's evidence that the intestinal absorption of 25-hydroxy-D3 is more efficient than vitamin D. It's a more polar molecule, and it's less dependent on formation of micelles. We talked about a number of different vitamin D functions. Across most of those functions, the 25-hydroxy-D3 has a higher biological activity, probably related to intestinal calcium absorption, but there are many post-absorption effects as well. And one of those examples is a more efficient, even at the same level of supplementation, a more efficient effect on reducing the incidence of tibial dyschondroplasia. I don't want to spend a lot of time talking about other metabolites, but the 25-hydroxy-D3 is quite non-toxic, and there's a very large safety margin because it is still under that tight control of preventing excessive formation of the active vitamin D form. So let's spend a few minutes talking about research in broilers looking at high D, 25-hydroxy-D3, and calcium metabolism. This is some work that one of my graduate students, Jennifer Saunders Blades, did, and I think it really underscores the importance of 25-hydroxy-D3, particularly early in the life of the bird. So in this experiment, we fed a control diet containing only vitamin D. We fed a diet containing only 25-hydroxy vitamin D3, and these were at comparable levels of activity. We fed 25-hydroxy-D3 up until 28 days of age and then switched to vitamin D. And then we fed vitamin D up to 28 days of age, and then we switched to high D. And so if you look at the birds that were only fed vitamin D, there's a decline in the circulating levels of 25-hydroxy-D3 that is not apparent when the birds are being fed 25-hydroxy-D3. And that seems to bottom out at around 10 days of age, and then whether that's through an increased ability to convert vitamin D into 25-hydroxy-D3 or whether it's related to an increase in the ability to absorb fat and therefore fat-soluble vitamins, we see an increase with age to 28 days. But it's important to remember that the level of 25-hydroxy-D3 in the blood is increased when we're feeding those birds 25-hydroxy-D3. Now, this is important because some of the data that I'm going to show you in a moment really has to do with effects that are particularly seen early in life. So when we supplement 25-hydroxy-D3 early in life. This is a similar, a different experiment, but it is a similar experiment. Control diet with only vitamin D, a diet with only 25-hydroxy-D3, again, the high D up until 28 days of age, and then vitamin D, or vitamin D up to 28 days of age, and then high D to 42 days of age. In this experiment, it's interesting to note that our highest bone breaking strength was observed when 25-hydroxy-D3 was fed through the entire life of the birds, but almost as effective was feeding 25-hydroxy-D3 only up until 28 days of age and then switching to vitamin D. So an increase in bone strength with 25-hydroxy-D3, even if it was fed only to 28 days of age. Now, in that same experiment, when we looked at cortical density, so we're looking at the bone mineral density, again, those two treatments had the highest level of cortical density, indicating a greater bone mineralization. And when we looked at cortical area here, so the cortical area is the cross-sectional area. Typically, the greater the cross-sectional area at the same density, the greater the bone strength. And in this case, the cortical area was greatest when birds were fed 25-hydroxy-D3 all the way through life. In a similar study, a little bit different approach, we fed vitamin D or high D, both at the same level of activity. We fed the two in combination, so essentially a double dose of vitamin D activity. And then we fed vitamin D plus high D in the starter only. And our final treatment was vitamin D and then in the starter, grower, and finisher, a decreasing level of high D supplementation. Overall, the high D treatment resulted in a nearly significantly greater level of cortical density in the femur compared to vitamin D. So we have a lot of data showing a positive effect on bone development. Many other labs have shown similar results, and so this is a fairly consistent outcome when 25-hydroxy-D3 is fed compared to vitamin D. This is some work out of Bob Weidman's lab. He has a bacterial chondronecrosis with osteomyelitis, or BCO. Many of you would probably recognize it as femoral head necrosis. And Bob has a challenge model where he raises birds on wire floors, and this increases the incidence of lameness because of BCO. And so in his experiment, he fed a diet that contained a high level of vitamin D, and then the two treatment groups were either tap water or water that was supplemented with 25-hydroxy-D3. And you can see that over the life of the birds, up until 56 days of age, there's a much higher incidence of lameness in birds that received no high D in the water, and this is even at a very high level of vitamin D activity. Looking at the data a little bit differently, the total incidence of lameness at the end of the experiment was much lower in the birds that received high D in the water compared to birds that received, again, that high level of vitamin D. So good indication that bone mineralization, bone strength, bone quality is increased when 25-hydroxy-D3 is fed. Now, when we look at bone growth, we need to remember that bones grow in length, but they also grow in width as the bird gets older. And so if we look at a cross-section of bone, so this is a section of bone, you can see that there are these canals, these Haversian canals, and the way that the bone forms around these canals is that the canal starts off fairly large, and gradually, as the mineralization takes place, you get the formation of the osteon, which is essentially a pore that runs along the length of the bone. Often there's a blood vessel that runs through it. And so bone is normally a somewhat porous structure. And we can see there's some Haversian canals here. You can see a blood vessel here, and Haversian canals with cavities or unmineralized regions in the center of varying sizes. So again, rapid bone formation. Carlos talked about this a little bit at the beginning. We've seen a great increase in the growth rate of broilers over the past decades. If we look at modern broilers, and even this is 20 years old, there's about a 4-fold increase in length over a 6-week grow-out period. So this is an incredibly high rate of gain. It's an incredibly rapid growth of bone tissue. Now, when bones grow in length, they grow along this growth plate. And so if calcium is deficient or vitamin D is deficient, we can see often defects occurring at the growth plate, like tibial dyschondroplasia. But I would like to point out that in addition to that substantial growth in length, there's also a huge increase in the diameter. And so we really have growth in 3 dimensions, but particularly length and cross-sectional area as the bird gets older. Now, the primary breeders, the geneticists, have done an excellent job of selecting for skeletal health, selecting for bone quality. But if there are impairments in nutrition, if there are impairments with vitamin D or calcium or phosphorus metabolism, it's not uncommon to see a loss of 2 to 6% of the broilers due to skeletal issues, particularly when we grow birds out to heavy body weights. And those problems can come through a number of different mechanisms. We don't often see tibial dyschondroplasia anymore, again, because of genetics, because of good nutrition. The geneticists have bred out a lot of the valgus and varus deformations, but BCO, bacterial chondronecrosis with osteomyelitis, is becoming an increasing problem in broilers, particularly rapid-growing, heavy broilers. And so obviously that has an impairment of the ability to get to feed. It causes lameness, it causes culls, it causes downgrades at the processing plant. Now, one of the things that I just want to finish up talking about is the consequences of rapid bone growth on meat quality and meat characteristics. So I mentioned that as bones grow, there are normal pores that form in the bone. So this diagram is a cross-section of the bone, and you can see that it's got a lot of pores, and that's a normal part of bone growth. When bone porosity is higher than we expect, or higher than is beneficial, we can see black bone syndrome, and I'll describe that in a little bit. Some of the work that we've done has shown that broilers fed 25-hydroxy-D3 have skeletal systems that are increased in their rate of maturation and reduced in their porosity. And so if we look at, this is a cross-section of a femur, you can see a couple of things. First of all, there's a region that's quite dense on the one side and a region that's much less dense on the other. But if we take a closer look, we can see that this poorly mineralized region, or low-density region, has a lot of these channels. And some of these channels go from the marrow cavity pretty much to the endosteum. So when those bones are cooked, so if we're looking at a bone-in thigh, some of the marrow that's present in the marrow cavity can migrate to the surface of the bone, and when it's cooked, it oxidizes, and you get this black bone discoloration. Now, why does that happen? This was some work looking at the effective growth rate, and this is within the same broiler flock. And so the birds that grew the heaviest, so the birds that were in the top 25% of the flock for body weight, actually had lower percent bone ash. Now, they may have had bigger bones, but they were less dense. The bottom 25% of the birds, so the slowest growing birds in that flock, had a higher bone ash. They had greater bone mineralization. So even though the bones were smaller in terms of cross-sectional area, there was less porosity or a greater density. So if we look at bone growth in broiler chickens, of course, broilers are marketed when the skeleton is still immature. And we can see that if we think about the bone as a structure, it's a much stronger structure if it has a greater cross-sectional area, even if there's a lot of pores. And so you can see that as broilers grow from 0 to 6 weeks of age, there is a substantial increase in bone cross-sectional area. Interestingly, if we look at broiler breeders at 59 weeks of age, broiler breeders actually have a smaller cross-sectional bone area, even though they would tend to be a higher body weight. Now, if we look at bone density increases at a much slower rate than cross-sectional area. And so if we look at a younger bird that's got a smaller cross-sectional area and a certain amount of porosity, with rapid growth, both the cross-sectional area increases, but the porosity increases much more quickly. And what tends to happen then is that there's a reduction in mineralization. And again, if we look at broiler breeders at 59 weeks of age, those birds have much greater bone density because those pores have had time to fill in. So what are the consequences for meat quality? Well, we did some consumer acceptance work. This is an experiment where we fed a control diet with only vitamin D. Well, let me back up. We fed these various treatments, we processed the broilers, and then we cooked the thighs and did a consumer panel and asked them to score the interior appearance. So they were asked to take a look at the bone and the meat next to the bone and give us their feedback on how much they liked the appearance. And so the control diet with only vitamin D, about 48% liked the appearance of the internal appearance of the meat, particularly next to the bone. About 41% disliked the appearance. Now, when we fed 25-hydroxy-D3 instead of vitamin D, the percentage of consumers that liked the appearance went up to 71%, and the percentage that disliked the appearance went down to 21%. When we fed high D only up until 28 days of age, still a majority of the consumers liked the appearance. So again, feeding 25-hydroxy-D3 early in the life of the bird still had a positive effect on the consumer acceptance. And then finally, when we fed 25-hydroxy-D3 only in the finisher period, essentially the same results as when we fed only vitamin D. So again, this stresses the importance of 25-hydroxy-D3, particularly in the early development of bone structure. And so it's, we often think of, well, if bone problems are occurring late, then the time to supplement 25-hydroxy-D3 is late in life. What we've found, and what a number of others have found, is that it's particularly important for 25-hydroxy-D3 to have its effect, that it be present early in the life of the bird. So in conclusion, proper calcium metabolism is essential to broiler productivity, and of course vitamin D nutrition has a critical influence on calcium metabolism. So we need to pay attention both to calcium itself and also to vitamin D because of the effect that it has on calcium metabolism. When we look at 25-hydroxy-D3 compared to vitamin D, we know that it has an effect on nutrient absorption. I didn't have time to get into that. But there are obvious impacts on bone development and bone strength that are mediated through the increased activity of 25-hydroxy-D3 relative to vitamin D, even when we provide them at the same level of supplementation. And that has carryover effect into the meat characteristics. So thank you very much for your attention, and I'm looking forward to our question and answer session at the end.
Hey, Dr. Corbett, thank you very much for your presentation. And just a reminder that if any one of you needs to make a question, please, you can select the space on your screen and you can write your questions, and at the end we will respond as much questions as we can. And now it's the turn for Dr. Alice Mallorca. Dr. Mallorca, the floor is yours.
Good afternoon to everyone. First of all, I would like to thank DSM for the invitation to speak about this relevant subject, and which was subject of many research projects. I would like to thank Lucas Bassi, my graduate student, who helped me to organize this presentation and was responsible for conducting these trials, assessing the use of phosphorus and developing strategic tools to optimize the use of phosphorus. So a brief summary of the topics of the presentation, the introduction. It's important for us to understand the role of this mineral, phosphorus, and the use of phosphorus. And for that, we have to understand some aspects related to the availability of phosphorus in the diet, especially in feed ingredients, phytic phosphorus, and also the solubility of this phosphorus in the diet. We talk a lot about solubility when we discuss quality of protein. However, it's important to measure solubility and digestibility of phosphorus as well. And very often solubility of phosphorus is forgotten. And I believe that we should emphasize this much better in order to understand how to better use phosphorus. I will talk about the interactions between phosphorus, phytase, which is extremely relevant for the use of phosphorus, and also vitamin D, as Professor Korber mentioned, also related to the calcium metabolism, but also involved in the metabolism of phosphorus. And vitamin D also can be used to increase the availability of phosphorus. And final considerations, points to think about when we talk about mineral nutrition. The first question that we ask ourselves about phosphorus, it's important to remember that we have been talking about precision nutrition, sustainability, the maximum use of the ingredients that we add to the diets. And for that, we have to understand what is the role of these mineral elements, phosphorus, for example. How can we better use phosphorus? The interactions of the nutrients, the form that this phosphorus is available in plant material, for example, and negative interaction with other minerals, with amino acids, is important to understand and in order to better use phosphorus. And finally, opportunities of reducing phosphorus levels and trying to prevent performance losses. So, what is phosphorus? Phosphorus is a very important element as calcium. Dr. Korver mentioned this. Phosphorus is present in many feed materials, and those plant materials which represent the basis of our diets, phosphorus is available at low levels and forms complexes with other elements, making it very difficult for the animals to break down these molecules and use this phosphorus. Phosphate has a crucial role in bone structure. 80% of the skeleton is in the form of hydroxyapatite. Phosphate is also a component of cell membrane and also has important roles in the energy metabolism. And how does the absorption happen? This is extremely relevant. The absorption of phosphorus happens in all small intestine, but we have a significant role of the duodenum because the pH level promotes the absorption. The higher solubility of phosphorus is seen at low pH levels. So basically, in the duodenum, so the body, we have the low pH in proventriculus and gizzard, and absorption happens mostly in the duodenum. When we see increased pH levels along the GI tract up to 6, we see that we have a higher formation of complexes and reduction of the solubility, and is less absorbed. And we have monohydrogen phosphate, one form, divalent, and dihydrogen phosphate, which are both forms. The absorption as calcium, we have two major mechanisms of phosphorus absorption, independent of sodium, is highly correlated to the calcium concentration. So it's a paracellular absorption and happens when we have high calcium levels. And this raises the first question when we think of phosphorus metabolism. How much have we reduced the phosphorus levels in our diets in these last 20 years with the introduction of phytases? We can project that these reduction started in the early 2000s, the reduction of 0.8 phosphorus in our diet. And in very aggressive diets, we might reduce 0.18 phosphorus according to the stage of the bird. And why is this important? Because the second mechanism for phosphorus absorption, calcium, when we see low phosphorus levels in the lumen of the GI tract, in this situation, phosphorus is dependent of co-transporters, and we see a strict relationship with sodium levels. And vitamin D is also acts on that. So this is now the moment to understand how can we use vitamin D metabolites to potentiate the levels of phosphorus and calcium. And this is related specifically with the cost of phosphorus, with the constant reduction that we have seen in levels included in the diets, because we hope that phytase will act, it will make this phosphorus more available. Optimization depends on several factors. Several factors will interfere, especially in the solubility, the structure of this phosphorus, and what are the factors involved in absorption. The first one is particle size. Larger particles, we see a longer retention time in the gizzard. This is related to pH reduction and solubility of phosphorus. So particle size is very important, interferes with the solubility of calcium and phosphorus. Solubility is higher at lower pH values. Structure of the fiber of this ingredient, of the structure of the complex formed with phosphorus. When we see inclusion of rice bran, for example, rich in phosphorus and more complex carbohydrates, but this also interferes with the availability of these elements, especially phosphorus. The form of vitamin D3, and Professor Korber explained this so well, the possibility of allowing us to provide a more active metabolite that will result in better performance of the birds. And finally, the use of phytase, which is being routinely used and also interferes with the availability of the phytic phosphorus. We also have important correlation with calcium, with solubility and availability. So we have strict correlation between digestibility of phosphorus and the levels of calcium in the diet. I'm sure that you all have seen this paper, a diet based on corn and soybean meal. We have increased levels of calcium in the diet, and we see a linear reduction in digestibility of phosphorus because of the formation of the complexes, reducing the solubility of phosphorus. And in the GI tract, we have binding of calcium and phosphorus, promoting excretion and reducing the absorption. This is an important study that helps us to understand the dynamics of absorption. We see two treatments here. The authors have used different concentrations of vitamin D3, calcium, and phosphorus in the diet. And these levels were optimized when D3 was used in high concentrations with normal or low calcium levels, showing that when we have a higher possibility of activating vitamin D3, we can optimize digestibility of phosphorus as well. And why does this happen? It's important to remember the effects of pH levels on the availability of phosphorus along the GI tract of the bird. We see significant changes in pH levels starting 2.5 to 3.5 for ventriculus and gizzard, and reaching 7 to 7.5 in the ileum. And this is very important, very significant, because the higher the pH, the lower the ability of absorbing phosphorus. So we have to use this short window of opportunity, which is this transition from the gizzard to the duodenum, to optimize the absorption of phosphorus in this segment, because this segment is more able to absorb. So all this transporter protein, all these cofactors are present, not only here, but more specifically in the duodenum. Solubility of phosphorus depends on different factors, especially on pH, and gradual increase of pH in the posterior segments of the GI tract. We have the formation of complexes that will negatively affect phosphorus absorption. We can have precipitation of phytic acid, binding to other minerals or amino acids, preventing the absorption and use of phosphorus. When we talk about optimizing phosphorus absorption, this paper shows that the concentration of phytate and correlation with phytase is extremely important. When we have high concentrations of phytate in the diets, this can be limiting. The phytase amount may be limiting, and this will restrict the use of phosphorus. So less molecules of phosphorus will be available for absorption. Considering the interaction of phosphorus and phytase, we have to remember that in the phytate molecule, we have an important element, inositol, where these phosphorus molecules bind. And when we have the breakdown of these molecules and release of inositol, we have the binding to intracellular receptor in the endoplasmic reticulum, opening calcium channels and stimulating calmodulin. And this can be partially this extra phosphorus effect, extra calorie effect that we see when we work with diets containing higher phytase levels. And myo-inositol is extremely important from different reactions, including modulation of the microbiota, is crucial for the growth and survival of cells, increases sensitivity to insulin, reduces total cholesterol, LDL, and triglycerides, also triglycerides in the plasma, reduces deposition of fat tissue, leading to more accretion of muscle protein, and essential for the bone formation, osteogenesis, and resulting higher bone density, which is the goal of this discussion today. So we have an important interaction of the form of phosphorus available in the GI tract, phytase action, releasing more or less phosphorus, and the solubility of this element to be absorbed. Here we have a study by Lucas Bassi in Turkey, and we worked with higher phytase levels. The diet was corn and soybean meal based, and we got significant responses. This paper was published last year in Poultry Science, and showing significant changes, not just in the use of phosphorus, but also the complexes formed by phytate with other minerals and amino acids. And it's clearly seen in this table. We see responses in digestibility of protein, calcium, and phosphorus as it was expected because of higher phytase levels, but sodium is also affected. And why is that? Because when we have complexes of phytate and protein, we have higher production of hydrochloric acid in the proventriculus to metabolize that, so we have higher amounts of acid reaching the initial portions of the duodenum, and we have a higher pancreatic secretion of bicarbonate, and this is related to higher moisture content in the droppings, higher moisture levels in the litter, and leading to heartburns and also higher ammonia levels. And this complexity is very high. Very often we just look at the calcium and phosphorus responses, but we have to have a broader view of the whole situation. And this study is important to understand the interaction of phosphorus and phytase. These researchers used a medium containing glucose, and they measured the excretion of sialic acid, which is an important mucin precursor. Whenever we have an aggression, be it physical, chemical, or biological, we have increased secretion of mucin as a protective mechanism, resulting in higher motility to eliminate this element. So higher production of sialic acid. When glucose is added to phytase, we don't see interaction, but glucose plus phytate, we see in 185% increase in the production of sialic acid, showing the clear anti-nutritional effect and the high metabolic cost. So we have increased mucus production to protect the epithelium, and we have to remember that the epithelium of the GI tract is responsible for using 25 to 30% of all energy and protein that the animals ingest. So we see a huge cost of these diets with high phytate level, high metabolic cost. However, when glucose, phytase, and phytate is added as well, we have a partial recovery and reduction in the production of sialic acid, resulting in lower amounts of sialic acid and mucin being secreted. So interaction of phosphorus, phytase, and vitamin D is very important. We have been working with lower levels of available phosphorus in the diets, and those two mechanisms that I explained. And since the early 2000s that we have been working with lower phosphorus levels, and we see higher evidence of the participation of the absorption mechanisms using phosphorus transporters from the lumen into the cell, with a significant and active participation of vitamin D. Vitamin D is even more important in this process of phosphorus absorption because our levels in the lumen are lower, and we have been changing the facilities, the broiler houses. We are not allowing sunlight to penetrate these buildings. So very probably the higher availability of more active forms of vitamin D will be more important to optimize the absorption of not just vitamin D, but calcium and phosphorus. Dr. Corver mentioned the D3 metabolites, what are the active forms. And we work basically adding calcidiol 25-hydroxy D3 can be used to replace vitamin D3, plain vitamin D3. When compared to calcitriol, it's more effectively absorbed. We have higher affinity to ligands, to vitamin D2 ligands, less need for a hepatic hydroxylation of D3, and it's a more bioavailable molecule. So this is why we are working with more active molecules, calcidiol. And Lucas is working on the studies, effects of supplementing high D and different levels of available phosphorus in broiler diets. 8 treatments for with and for without high D supplementation, and gradual reduction of the phosphorus levels, and all the diets contain 1,500 units of phytase. And we measured feed intake, average daily gain, which was significantly improved when we reduced the available phosphorus, or better, when the phosphorus levels were maintained, we were able to maintain average daily gain. No significant changes in feed conversion rates. However, when we supplemented 250 units of high D, we saw statistically significant improvement in average daily gain and improved feed conversion rates, and no interaction between these phosphorus levels and high D supplementation. We try to assess digestibility, and we saw increased digestibility of calcium and phosphorus with the reduction of the levels of calcium. Whenever we reduce a nutrient, we have a higher absorption rate, and also improved levels with high D supplementation, both for digestibility of calcium from 54 to 57, and digestibility of phosphorus was also improved from 68 to 72%, showing that this is allowing us to better understand the performance improvement we see with high D supplementation, higher availability of phosphorus, and less interference with the phosphorus absorption. We collected tibia of these birds, and we measured ash content, calcium and phosphorus in the tibia. We saw improved levels with lower phosphorus levels as to the phosphorus amount in content in the tibia, and a higher ash content when we supplemented high D. It was statistically significant, P lower than 0.001. But we wanted to challenge these levels even more. In the previous diet, we used 0.36 of available phosphorus. We conducted another trial, similar experimental design. However, we challenged the phosphorus levels even further for treatments with and for without high D, and for different concentrations of calcium and phosphorus in the diet, always respecting the 2-to-1 ratio. Because we know that there's a significant correlation. We see drastic reduction in phosphorus and calcium. We measured circulating levels of alkaline phosphatase, calcium, circulating calcium, and showing that alkaline phosphatase is a very important enzyme in phosphorus metabolism, and possibility of having higher absorption of calcium and phosphorus, higher digestibility, and also circulating levels of vitamin D were also higher when we supplemented high D. Significant response as to we saw reduction in average daily gain and worse feed conversion rate, but with high D supplementation, we saw a better response as to feed conversion rate when high D was supplemented. So in summary, when we compare just the effects of 250 grams per kilo of high D, we were able to see a significant effect in feed intake and average daily gain and feed conversion rates, digestibility of calcium. This was clearly seen in both trials, digestibility of phosphorus as well, and ash content and the bones, showing that when we work with low phosphorus levels, we can optimize the absorption by supplementing high D. Final considerations: the understanding of the reactivity of phosphate with other components of the digester in the GI tract of the birds is essential for maximum use, and we have to optimize because of cost issues and because of sustainability issues as well, and we have to better understand how phytate affects the use of phosphorus. Higher doses of phytase can be beneficial as to environmental impact and animal performance. Inclusion of high D supplementation improves significantly performance, digestibility of calcium and phosphorus, ash content, independently of the available phosphorus levels. I would like to thank the group of animal research in non-ruminants at the Federal University of the State of Paraná, the graduate, undergraduate students, the researchers, part of this group, because they helped us to generate most of these information. Special thanks to the Federal University of the State of Paraná. Our doors are open for the community, and will continue conducting significant research that will help Brazilian poultry industry. Thank you.
And now we are going to open the question and answer session. So we will have about 20 minutes for this. And the first questions are related to skeletal development, skeletal quality. And the first question is related to the supplementation of the vitamin D3 levels in the experiment that you showed us, Dr. Corbett. Could you comment how much was the vitamin D3 level in those experiments?
Sure. So our control was vitamin D at 3,000 international units, and the level of high D supplementation was 69 micrograms per kilogram, or the standard recommended dose for high D.
Okay. Yeah, thank you. And regarding to those levels that you use in those experiments, do you have a comment how much is the vitamin D level that the broilers of today they need to be included in their diets? Are the similar levels or probably higher?
Right. So the levels that we used are fairly typical in Canada. I recognize there's a range of levels. We tend to work probably on the lower end of practical in our experiments, but compared to the actual requirement. So if you look at the requirement in terms of preventing rickets or preventing tibial dyschondroplasia and allowing for growth, the requirement is actually quite low. I've seen the 1994 NRC was around 200 international units. Now, if you start looking at meat quality, and if you look at immune function and skeletal optimization, it's probably higher than that. And so 3,000, we're comfortable that that's practical. It also allows us to be close to the maximum level of supplementation in most countries where when we combine vitamin D and 25-hydroxy D3.
Yes. However, our internal research has shown us that probably the broilers today, due to the higher feed efficiency, probably they will need higher levels, not just vitamin D, or other vitamins, because the feed efficiency reduces the amount of feed that they receive in the short period of the cycle.
Yeah, that's a really good point, because we, as nutritionists, always think about nutrient requirements in terms of percent of the diet. In reality, birds require nutrients in terms of proportion of body weight and rate of gain. And so with higher body weights, with faster growth rate, with lower feed intake, we do need to address that in our formulations.
Okay, thank you. And with the increasing of the slaughter weight of the broilers today in many Latin American markets and also in Europe, would the use of 25-hydroxy D3 to be included until the end of the cycle to be an important tool to reduce the losses, for example, in automated slaughter, automatic deboning?
Yes. So we typically see, well, first of all, we see more bone problems the heavier the birds get. And so because of the positive effect of 25-hydroxy D3 on bones in general, we think that there's an advantage. The other thing is that, so if we look at the best results that we obtain, and typically others as well, the best results are obtained when the birds are fed high D throughout the entire life. For economic reasons, sometimes people include high D for only part of the bird's life. If you're going to do that, it's most important early on. And what early means depends on how long you're going to take the birds out. So, for example, in our experiments, we kept the birds to 42 days of age, and we got almost the same response, not quite, but almost the same response when we fed high D from 0 to 28 days. If you're marketing birds at 56 or 70 days of age, I would expect that you would want to include high D for a longer period of time because of the benefit, the carryover effect on bone development to the end of the life.
Okay. And we have some other questions regarding to the black bone syndrome. And the black bone syndrome occurs more frequently when the broilers are young or are processing at younger ages. So how can be reduced the occurrence of black bone syndrome in the broilers today?
So it's not the right answer commercially, but if you slow down growth rate, you reduce the porosity and you reduce the leaking of marrow. Now, that's not a good answer for industry. So what we want to do then is have the rapid growth rate, but reduce the porosity other ways. And so what we found is when we feed 25-hydroxy-D3, it allows the birds to deposit bone more quickly, to reduce the porosity and reduce the incidence of black bone.
Yeah, and I have other question, but I think both of you can respond to this, or I would like to receive the comments from both of you. So what recent advances have been made regarding to the ratio of calcium and digestible phosphorus in the formulation of broiler diets?
Dr. Mallorca, would you like to go first?
Bom, essa é uma pergunta extremamente intrigante para nós, né? Nós estamos...
Intriguing question. We have been working on that, trying to define this ratio, because when we started using phytase in this last 20 to 30 years, we saw the change in this ratio. The ratio is still the same in the bone, but the availability, digestibility of the minerals has changed. And in the last 5 years, we have increased phytase levels even more. So when we talk about digestibility, we have tried to better understand the interactions that we see in the diet, especially the formation of complexes of phosphorus in the fiber and fibers, because we have not just to think of the breakdown of phytate, but the bond of phytate to the fiber, the type of fiber. So in our lab, we have tried to better understand these relationships. Phytase is relatively new. We have been using in the last 20 to 30 years. We have adjusted the levels of phosphorus and calcium because we were expecting that higher levels of phosphorus would be released. And we saw increased digestibility, not just because of the breakdown of phytate, but also because of lower levels, and this results in better solubility of phosphorus, and this is why we have seen these changes in the calcium to phosphorus ratio.
I think one of the things that we can look forward to, I don't think we're there yet, but one of the things that we can look forward to is applying the availability concept to calcium as well as phosphorus, because we know that In limestone, for example, there's a huge variation in the digestibility. And we assume that limestone is 100% available, but we know that it's not really. And so if we can understand calcium digestibility and formulate diets based on calcium, digestible calcium, as well as digestible phosphorus or available phosphorus, I think that we can do a much better job of meeting the needs for calcium and phosphorus, optimizing the use of phytase as well, because as we heard, there are interactions between calcium and phosphorus, and if we have our calcium number wrong, we're probably not allowing the bird to use the phosphorus and take full advantage of the phytase that we're feeding. So Rosalina Angel from the University of Maryland has been working a lot in that lately, and I think that in the future, that's how we'll be formulating diets as well. Not just available phosphorus, but available calcium.
Okay, thank you. Okay, Dr. Korber, you present us some results about the usage of 25-hydroxy-D3 as an advantage for the broilers in terms of better calcium metabolism. And Dr. Mallorca, you present some similar or good results with the usage of high-D in terms of phosphorus metabolism. So in practical terms, how can we use those results in terms of synergism between 25-hydroxy-D3, high-D, and phytases? For example, can we go further in a bigger matrix of calcium and phosphorus and get some other savings for the cost of the diets or something like that? It's for both of you. Sorry.
I believe that Lucas is trying to better understand exactly this process. And although we used higher phytase levels, we used a supplementation of 4,000 units of vitamin D, which is quite high already. Even with those high levels of vitamin D, with supplementation of high D, we were able to optimize not just performance of the birds, but also bone mineralization. So we are trying to better understand up to what point we can reduce phosphorus levels and optimizing the absorption, especially by supplementing high D. I believe that we will be able to show this in our trials, at least according to our initial data, measuring circulating calcium and phosphorus levels and also bone mineralization.
Do you want to add something?
Sure. That was a great answer. But I think one of the things that we need to remember is that there are two different mechanisms. So phytase works by increasing the free phosphorus available for absorption in the gut. The 25-hydroxy-D3, phytase also liberates calcium. The 25-hydroxy-D3 works at the level of the intestinal cell in order to upregulate the active transport of both calcium and phosphorus. So we can use those two things together. And so if we increase the amount of free calcium, free phosphorus available for absorption, and remember the active transport, the vitamin D dependent transport is most important when levels are low of calcium and phosphorus. At high levels, there's the paracellular transport route. So I think that gives us the opportunity to reduce calcium, which probably is not as nearly as important economically, but also phosphorus even further. And as Dr. Mallorca pointed out in his presentation, we need to make sure, though, that we keep in mind how much phytate, how much phosphorus bound to the phytate molecule is actually present. Because if we have low phytate diets, phytase itself is not going to provide phosphorus.
Yeah. And actually, you mentioned that calcium probably is not so much important than phosphorus in the diet cost, but I think if we can reduce the calcium level in a diet, other ingredients can be included in a higher level, for example, ingredients that supply energy, and that will help at the end, right?
Sure, yeah.
Okay, and now we have more specific questions about phosphorus. And there's one related to the content of phosphorus in different forms of phosphates. For example, it's why is the phosphorus content in the decalcium phosphate less available than a monocalcium phosphate?
Por causa das relações cálcio e fósforo.
Because of the calcium to phosphorus ratios in these different sources, especially mineral sources. The calcium to phosphorus ratio present in these sources will determine the higher or lower availability because of the complex formation and solubility of phosphorus that I explained early in my presentation, but the ratio will determine the availability.
No?
I don't have anything to add. That was a complete answer.
Okay, perfect. So there's another one regarding to the pH in the intestine. And Dr. Mallorca, could you extend your explanation about the importance of the pH in the intestine in terms of absorption of phosphorus, and how can be how the absorption of the phosphorus can be affected due to the changes in the pH?
Essa absorção de
The absorption of phosphorus and of other minerals will depend first on the solubility. Minerals in general are more soluble in acidic pH and low pH. As we increase pH levels, we reduce the solubility because we are allowing for the formation of complexes which happen in more alkaline environments. So formation of complexes happen, and for example, when we have activation of phytase in low pH, is exactly to prevent the formation, the breakdown of phytates to happen before the formation of complexes with calcium. Otherwise, the phytase won't be able to break down these bonds. Então, low pH promotes solubility of minerals in general, resulting in higher possibility of absorption.
Regarding phytases, how much would be the dose of a phytase to fully reduce the phytate until inositol? It depends on the diet, or it depends about the chicken age?
Sim, acho que o trabalho...
Yes, I showed the paper by Dr. Carlson showing exactly this. At some points, phytate is limiting, other points, phytase is limiting. So we see a multifactorial interaction between the concentration of phytate, action of phytase, and consequently the solubilization of phosphorus in low pH levels. And will also depend the type of phytase that you're working with, because this will also define what are the optimum levels in phytase units for each type to be more efficient, to be able to break down phytates and release myo-inositol to have the beneficial effect. This will depend on different factors: age of the birds, type of diet. No, we see there's a huge complexity of ingredients. I believe in the role of phytase to digest fiber. So these elements, considering phosphorus, fiber, calcium, we usually think in compartments, but this is not what happens, because the plant cell is extremely complex and depends on the action of different enzymes, breaking down these fibers, allowing this phosphorus to be more or less available, for example, at lower pH levels. If we use higher particle size, for example, we have reduction in the pH proventriculus and gizzard, and high digestibility of protein in general. So this will depend on different factors. One of our papers showed that xylanase has also an important role in determining phytase activity. They are not competing for the binding site, but xylanase helps to break down this fiber. We'll have more phytate available in the lumen for the phytase to act on it. So it's complexity of the environment. So we work with low phosphorus levels in our diets, and we have seen higher digestibility protein, for example. So these chemical interactions between the elements have to be better understood to allow for better use.
Okay, thank you very much for your answers, and also for to Dr. Korber. And just because the time is over, so I want to say thank you to both of you, to our main speakers, and thanks to the audience to stay here until the end. And just to remind that we have some other questions that were not answered yet, and we will pass these questions to the speakers, and then we will try to send the responses to you. And please don't forget that we will have a channel in YouTube when you can see these webinars that we have presented so far. And additionally, we are preparing a kind of article presenting the two conferences that we have today. So you will receive a communication of those articles. And if you have further questions, please, you can contact our representatives of DSM in your countries. And for me, thank you very much for your attendance, and we hope to see you soon. Thank you very much.